All right, so now we're on to section 1.2. So once again, if you're following along on video, make sure you print out the PDF that is in your Canvas shell. And what we're going to start off with is another thing that you probably got a taste of in intermediate algebra, but this class, college algebra, we are going to use this so much. Okay, so this is something that you need to be good at, and that is the idea of using interval notation. Interval notation is going to come up almost every section as we describe graphs, as we solve equations and inequalities through graphs, all sorts of things. As we go through this section, we talk about domains and ranges of functions and relations. You're going to use interval notation all the time. So my first several examples deal with that, just making sure we're up to date and feel good about it. Also, if you're struggling getting to know interval notation, graph something on the number line. Okay, the interval notation agrees with the number line. I'll do that for the first couple. So here we go. This is my example one. We are asked to write this inequality as interval notation. By the way I've written all these inequalities is in what's called set builder notation. So if on MyMathLab they refer to set builder notation, that's what these examples are already written in. Okay, so this is what this means is it's the set of x's. This bar you pronounce such that, and then there's going to be a description over here. So it's the set of values such that the values are greater than 4 and less than or equal to, or excuse me, greater than -4, less than or equal to 9. Now this first one I'll graph just because I want you to visually see the relationship between our interval notation and graphing things on the number line. Okay, so here's my number line. If you don't need to do the number line, then that's fantastic, because I will not ever bring up number lines in this class again. I don't think. Maybe I'm lying. Okay, what are the endpoints of my interval that you can see from these sets in the set builder notation? Okay, I've got -4 as one of my ends, and then 9 is the other end. If I was shading this, where would I shade? According to the way this is written, what part of the number line am I going to shade? Perfect. Whoever said that was exactly 100% right. You're going to shade between these two. This is the values that are bigger than -4. So bigger is going to the right, but at the same time, they're less than 9. So that's to the left. So these red values here are the values that are at the same time bigger than -4, but also less than 9. Now, old school, when you're doing this in middle school and high school, what would you have put at the -4 end of this interval on the number line? You'd put a circle, an open circle, because there's no equality. If you took intermediate algebra at Polk State, or I think most of the instructors do, I know I do, there is a new notation. Okay, for the graph, I don't really care, but I'm using this because it makes sense for our interval. When we have no equality in interval notation, what we're going to use is we're going to use a parenthesis. So my parenthesis is open in the same direction as my values. Again, old school. Okay, what you probably learned in middle school or high school, what are you going to put at the 9 end of this? A filled in circle, right? A dot, and that's fine. If I ask you to graph on a number line, you're more than welcome to do that. But the new symbol for it is a bracket, a squared off bracket. So now that I've graphed this on the number line, this tells me everything I need to know about my interval. And so interval notation always, 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 every time, every day will be written like this. You always put your lower bound on the left, comma. Then you always put your upper bound on the right. You never reverse that. It's not good math to do that. It's like writing, I don't know what the English equivalent is, so I'm not even going to pretend to know. Okay, but you just don't do it. And then on either side, you either put a parenthesis or a bracket, depending on what the context is. So I'm just gonna do one of each right here. Okay. So now here we go. Let's now put this interval right here in interval notation. According to my picture, what's the lower bound of this? -4. What's the upper bound of this interval? What am I going to put at the -4 end of this interval? There's no equality, so I put parenthesis. What am I going to put at the 9 end of this interval? There is equality, so I put a bracket, and there you go. There's your interval notation. Does that make sense? Anybody got a question? Okay, then what I would like you to do, please, is exercise 1. Okay, so I'm not going to draw on the number line. If you did, that's totally 100% fine. Do what you need to do to get to the right place. So on my interval that's described here, what's the lower bound of this interval? What's the upper bound? What am I going to put at the -11 end? There's equality, so I put a bracket. What am I going to put at the 0 end? Perfect, well done. Yes?
Lower bound, upper bound, that's just the lowest number.
Lowest value, highest value. Yeah, exactly. That's probably a better way to say it. Thank you. All right, so here's the next example. This is example 2. So it goes like this. I want to now write interval notation, the set of x's such that x is bigger than 6. So one more time, I am going to do this on the number line just to show you what's going on here. So here's my number line right here. What is the only boundary that I'm given in this set of values? 6. Now, if I was to shade, which way am I going to shade with respect to 6? If I want all the values that are bigger than 6, am I going left or right? To the right, yes. Does it ever stop? No, I'm not given any stopping point on this. That's important. What am I going to put at the 6th end of this? Okay, for the same reason as over here, there's no equality, so I'm going to put a parenthesis right there. Okay, so let's write this in interval notation. What's the lower bound? What's the lowest value in this interval? 6. Better answer your question. The reason I call it the lower bound instead of the lowest value is a technical math thing. 6 is not a value that's part of the interval because there's no equality. Okay, saying lower value, I don't care, but I'm just letting you know that's why I use this terminology instead. Okay, there was a reason. Just took me a second to remember. Okay, now here we go. What's the upper bound on this? Perfect. You all know this. There is no upper bound. It doesn't stop. So the notation for that is we use this symbol. It's different than the car. We use the infinity symbol. It's like a 8 that's been out too late on a Friday night. Okay, it's passed out. So there we go. Infinity is not a destination. It is a direction. Okay, you never get to infinity. And because of that, at the infinity side of this, no matter what else is going on, you always use a parenthesis at infinity. You'd never use a bracket on the infinity side because you can never equal infinity. What am I going to put at the 6th side of this? And the reason I use a parenthesis is because of the no equality. Okay, so those two things are separate decisions. Okay, so just keep that in mind. So if you would for me, please do exercise 2. Values greater than or equal to 3. All right, so if you use the number line, perfect. It's a good tool. What's the lowest value? What's the lower bound of this? 3. Because again, this is greater than 3, so that means all the values are bigger. So that means this is, what's the upper bound? Infinity. Great. This time, what am I going to put at the 3 end of this? Why am I putting a bracket? Because of the equality. There's a bracket that's going to go there. Beautiful. Well done. What am I going to put at the infinity side? Always. The infinity side has nothing to do with the equality or inequality. Give example 3, the one in the left-hand column. Give that a try. Okay, the x is less than or equal to -9. All right, this time I've changed the direction of the inequality, so let's see how this works. Let's see if you figured this out, and if you made a mistake on this, it's okay. It's a little bit different, so forgive yourself and just learn, and it's all good. So this one, since all my values now are less than or equal to -9, this time the -9, is that still the lower bound? No, it's now the what? Okay, it's the upper bound. Great. So I'm going to put the -9 on this side. So what's going to go on this side since there's no stated lower bound? Perfect. I heard a bunch of you say it. It's beautiful. We're going to put a negative in front of our infinity. So if you forgot to do that or didn't know to do that, that's okay. Okay, we're learning here. So negative infinity means I'm going in the negative direction on the number line. What am I going to put at the negative infinity side? Always. What am I going to put at the -9 side? Great. Do exercise 3 right next to it. Just take you a moment or two. Okay, so this is very similar to example 3 with just one minor difference. So once again, the value 7 is which bound? It's the upper. Great. So the lower bound is going to be wonderful. You're doing great. The infinity side always gets a parenthesis. And why does the 7 side get a parenthesis? No equality. Beautiful. Any questions, comments, or concerns so far? I've got one more thing to tell you about interval notation, and that is how are we going to write all real numbers? So I'm just going to give you 30 seconds. See if you can figure it out. Okay, and if you can't, that's okay. This is a new and novel situation. All real numbers means I'm going both ways on the number line. Okay, so see if you can write something down there. All right, so all real numbers. If I'm talking about the entire number line, and if you had to just guess, okay, what do you think the lower boundary is? Great job, wonderful. What do you think the upper boundary is? I'm sorry, I didn't hear what you said. Perfect, yes, that's what I wanted you to say. Just wasn't positive. And then at both sides, we're going to put a parenthesis. So if you didn't know that before, that's totally okay. Okay, remember, we're learning here. I don't expect you to know all this. I just wanted to see if you could hazard a guess on that. So negative infinity to infinity means I'm going both directions forever on the number line because all real numbers. All right, so that's interval notation. You're going to practice that a little bit because you're going to use that in just about every section that we go through in this class. Okay, we got about 15 minutes to go in our class, so we're going to get started talking about the idea of a function, which is a super important concept in this class. Everything we do from this point forward is the algebra of functions. Okay, so it's important that we understand what a function is. So, before I can tell you what a function is, I've got to define for you what a relation is. A relation is short for relationship. And the way in math, the way in algebra we express a relationship is by using ordered pairs. So a relation is just a set of ordered pairs. Nice, simple definition, hopefully. Now, we have several ways to denote sets of ordered pairs. So we're going to go through, and you see at the bottom of this first page, I've got 3 listings of ordered pairs, and we're going to start with those examples, and then we'll turn the page and we'll look at some other ways that we can denote sets of ordered pairs. So give me a moment. I'm going to write these down. You already have them, and then we're going to talk about what is a function and a couple of other attributes of these relations. So the first relation I have is relation that's called A. And relation A is these ordered pairs, -2, 3, 0, -6, 3, 5, and 7, -2. That's our first relation. The second one we have, I've labeled relation B. It is point -5, -6, -3, 7, 2, 1, -4, and 0, 0. And the last of these first few examples is relation C. And relation C just has 3 points, 2, 4, 3, 4, 7, 4. Now, I have something in particular about each of these examples. There's a reason for each of them, but I just want you to know there's nothing special about the number of points in each of these. Okay, that there's nothing. I just get bored after a while. So this one has 4 points and 5 points, and then I get really bored, and that one has 3 points. Okay, so on the next page at the top, we're going to come back to these, but the first thing I'm going to define for you is what is a function. Okay, so you can see at the top there is a place to write what a function is. So a function is a relation, meaning it's a set of ordered pairs. So a function is a set of ordered pairs. That's all this word means. So a function is a set of ordered pairs in which each x value corresponds to exactly, and underline that because that's the key word in this definition, to exactly one y value. So as we define the relationship, as we look at these defined relationships and ones that are to come, we want to notice, does each x value correspond or is it related to exactly one y value? No more y values. Okay? So if an x value has more than one y value, it's no longer a function. Now, another way to think about this, kind of a more visual way, I'm not going to write it on the board, but you can write this right below. It says a visual explanation. A function is a relation in which each x occurs once. Function is a relation in which each x is listed or each x occurs once. Sometimes that's an easier way to think about this. And I want you to have the best time of it you possibly can. So the math definition is a function is a relation in which each x value corresponds to exactly one y value. And then the visual way to, when you're looking at these relations, is a function is a relation in which each x is listed one time. Everybody got that down? Okay, because this is important. We're going to talk about functions the rest of our class, meaning the rest of our 16 weeks together. All right, so we're going to look at these relations, and we're going to determine, are they functions, yes or no? So you're going to, I'm going to give you 10 seconds. I want you to look at the relation and then write down function or not a function, and then we'll validate. So look at relation A. Is relation A function or not a function? So write down what you think. Is each x listed once? Meaning, does each x get exactly one y value? Okay, what do you think? Function or not a function? Okay, function. Okay, so in case you didn't know, I understand we're learning here. This is probably new for most, if not all of you. The reason it's a function is, are any of the x's repeated? -2, not repeated. 0, 3, 7. What that means is each x gets exactly one y value. There's no second y value that goes with -2. -2 goes with only 3. 0 goes with only -6, etc. Okay, that's why that's a function. All right, 10 seconds. B. Is B a function or not a function? Don't shout it out, please. What did you write down for B? Function or not a function? Why? The x value 1 occurs twice. So what that means, the reason this violates the definition of function, a function, each x value goes with exactly 1 y. How many y values does the x value 1 have? 2. It has the value 2 and it has the value -4. That's why this is not a function. All right, I have a particular reason, not just boredom, for example C. So 10 seconds, is C a function or not a function? So I give this example on purpose, okay, because this is a commonly missed one. All this says is each x value gets 1 y value. Does it say that the y values all have to be different? No. That's going to actually, spoilers, that's going to be something different that we come to about halfway through the class, where you have a special kind of function that each x value gets a unique y value. Be excited. It's going to be fantastic. But in the meantime, it says nothing about the y values. Okay, it doesn't say that they have to be different. So all that matters is each x listed once here. I've got the x value 2. Does 2 repeat? Does 3 repeat? Does 7 repeat? No. So I understand why some of you said this was not a function. Okay, that's why we do this example. But each x value goes to exactly 1 y value. Now, they do happen to be the same y value, but that doesn't matter at all. Okay, so this one right here is indeed a function. Something else about these that we're going to talk about, this is going to be the last thing I define. So if you could please, I'll have more of these, but if you could bring your worksheets back to class so we can pick up where we left off. This is the last thing for the day. We've got 6 minutes to go. There are some other words that I need you to be familiar with. The next one is called the domain of a relation. Have you heard this word before? Does anyone know what the domain is? It's the set of x values. Okay, so the domain is the set of x values. And the corresponding word is the range. And so the range is the set of y values. So I'm going to look at relation A. Relation A goes like this. You can see it. It's on your paper. So the domain, I'm going to abbreviate DOM. The domain is the set of x values. What are the x values of this relation? It's not technically necessary to write your x values or y values in number order, but it is very helpful. Okay, it's usually done, so I'm going to write them in number order. So here's what I'd like you to do, why I call the roll today, is I want you to do the range for this, and then the domain and the range for the other two relations. Okay, so here we go, domain and range. So the range of this function is the set of y values. I'm going to write them in number order. So -6, -2, 3, and 5. If you have any questions about these, let me know, and that'll be how we end our time. So the domain of relation B. The domain is -5, -3, 0, and 1. The range is -6, -4, 0 to 7. Question you may have is, hey, Mr. Perkins, why didn't you write the number 1 twice? You don't have to. You don't need to repeat things when you write down sets. So if you did, erase the other 1. You don't need it. Once you put it in the set, it represents all ones there might be. And then finally, over here for C, the domain of this one is 2, 3, and 7. And then last but not least, the range of this last one is just the number 4. All right, so before I let you go, any questions that you have for me today? So here's what I would recommend you do. 2 things before I see you again on Monday. Thing number 1, register and get into my math lab, even if you have to do the free 2-week trial. And then we completed section 1.1, so I would at least do the homework and the quiz for section 1.1. If you want to start section 1.2, that's fine, but we didn't finish it. I wouldn't take the quiz yet, but get through section 1.1. If you need anything else, email me or you can come down and talk to me. I'm so glad you're in my class. I'll see you Monday.